Welcome back. I forgot to change my first slide, but we're going to talk about the actual unit circle and how we can use that today. But for starters, we're going to build it. If you are absent, I have stuff for you to get when you return. So you'll need a sheet of the circle thing that you'll have to cut out, and we're going to build this and glue this into our notes. So you're going to start off by cutting out the circle in the supply container, get a ruler and whatnot, neatly cut out this circle, label the X and Y axis, and label the 0, 90, 180, and 360 degrees on each axis appropriately like this. So you cut out a circle that looks like this. Next, you're going to grab a 30, 60, 90 triangle and label all three sides like we did from yesterday. So the 30, 60, 90 triangle, remember, that was the square roots of 3 over 2, the 1/2, and those were our order pairs. So right here, that's kind of what we're looking at. And we're getting these links from yesterday talking about these special right triangles. The X value right here was square roots of 3 over 2. The Y value is 1/2. And, of course, the radius for the unit circle is 1. So that's our hypotenuse of this triangle. Once we have this here, we're going to line up our ruler with the hypotenuse and draw a straight line from one side to the other like this. And I'm going to draw a straight line like that. And then I'm going to remove, and I'm going to repeat this, I'm going to repeat the process, but I'm going to reflect this over the y-axis on this side and do the exact same thing. So now I should have something that looks like this. And we do want to make sure we're going to have 3 different colors we use besides black. So I would recommend using 3 colors because it can get a little chaotic and messy, and it would help to kind of be colorful and a little bit organized to draw your attention to certain things. Okay, using the reference triangle in quadrant 1, what would be an ordered pair that touches the edge of the circle? Well, we saw this kind of already, but if we look at our dimensions, we go over square roots of 3 over 2 from the origin, and we go up 1/2. So we would say that point right there would be square roots of 3 over 2 for our X and 1/2 for our Y. We're going to go ahead and label this on our circle. And we're going to go ahead and label this as 30 degrees. And typically I'd write this in between the x-axis and that terminal side, but I'm going to write this right there just so it kind of stays not so cluttered. Okay, so that's what we have. And let's see. Now grab the same triangle that we just got done using, and we're going to flip this over and rotate it so that we get this piece right here. So now we have square roots of 3 over 2 is the higher piece, and 1/2 is the x value. So we can take that same triangle we used, and it will probably be on the other side. So if you want to use this triangle and write the links on the front and back, I only have squares on one side. So, but you can do that, and that way you can kind of do this real quick. And we're going to do the exact same thing, but we want to use a different color this time. So I'm going to grab my ruler, line it up with that hypotenuse, draw a straight line there. Then I'm going to flip that same triangle over to the other side like this and flip it over the y-axis. Use your ruler, draw your line, and bam, there we go. And then going back to what we just got done doing, let's go ahead and line this up and figure out what that ordered pair would be. If I line that up, I'm going over the x direction 1/2 and up square roots of 3 over 2 for the 60 degrees. We'll go ahead and label that 60 degrees as well. So I'm going to keep everything kind of color-coded, nice and neat. And now lastly, we're going to grab the 45, 45, 90, which looks like this, and we're going to do the exact same thing. Draw our line, flip it over the x-axis, y-axis, draw our second line, and now let's write our order pairs and our angle measurement. So our order pairs for there is square roots of 2 over 2 and square roots of 2 over 2. And what about the ordered pairs at each one of the axes parts? So think about this for a second. At the 0 degrees and 360 degrees, right? If our radius is 1, we've gone to be on that edge of that circle. We've gone over 1 and up nothing. So our ordered pair here should be just 1, 0. If we look at the 90 degrees, we've gone over left and right nothing, but we've gone up 1, so we should be at 0, 1. If we go in 180, then we should go over in the negative direction, a -1, because that's our radius, and up or down nothing. And then if we do the bottom one, we have gone over left and right nothing, but down 1, so that should be 0, -1. So you do need to be familiar with everything here so far, and I'll kind of give you some pointers, but you don't have to memorize those axes. Just think about it. Know that the unit circle has a radius of 1, and then we'll talk about some ways to kind of get some of the other things. So let's review and label some of our unit circles in radians. Recall how many radians are in a full rotation, and we said that that was 2 pi. So then half of that would be pi, right? And this should be labeled on our big unit circle by the way that we're gluing in our notes. Halfway between 0 and pi would be pi over 2. We've talked about this last semester. And then halfway between pi and 2 pi would be 3 pi over 2. And so now we have something that looks like this. Your unit circle should look something kind of like this. All right, now let's look at, am I doing radians now? And I just don't have that up there. Oh yeah, now the angles in quadrant 1 is radians. Okay. So what is half of pi over 2? So between 0 and pi over 2, that would be the same thing between half of 0 and 90 degrees, right? So halfway between 0 and 90 is 45. So halfway between pi over 2 and 0 would be pi over 4. I'm going to label that, and then I'm going to use what we did last unit to just kind of see what these are. This is a kind of a lot of work, but it's just to remind you how we got this stuff, how this stuff makes sense. You're not going to actually be converting these. I don't want you to be. You don't have time for that. The other stuff that we're going to be doing. So, but I'm just going to show you why these two things are what they are. So if I have a little bit out of order, what is going on? Okay, it should have said that first. So the 30 degrees, and then the conversion factor we use is pi over 180. So that gives us 30 pi over 180, and that would simplify to just pi over 6. So 30 degrees is the same thing as pi over 6. And then we're going to do the same thing for the 60 degrees using our conversion factor of pi over 180. And we get 60 pi over 180, which is just pi over 3. So, and then we can label them kind of like next to the angles, kind of inside there, next to the degrees. Oh, I hate it when my stuff does not, when it's all jacked up like this. Okay, so remember SOHCAHTOA. What did we notice about how sine, cosine, and how sine and cosine at 30, 45, and 60 degrees relates to ordered pairs of these angles? Consider the following triangle, right? This is square roots of 3 over 2, 1/2, 30 degrees, blah, blah, blah. Notice if I were to use trig ratios for sine, the opposite side of the 30 degrees is 1/2, and the hypotenuse is 1. So if I do sine of 30 equals 1/2 over 1, I'm left with the sine of 30 is equal to 1/2. So if I asked you what is the sine of 30, your answer is 1/2. If I do the same thing with cosine of 30, I'm referencing that reference angle of 30 degrees, and the adjacent side of that is square roots of 3 over 2, and the hypotenuse is 1. So the cosine of 30 degrees is equal to square roots of 3 over 2 divided by 1, which is just square roots of 3 over 2. Notice, with our ordered pair, the sine was our y value that we had listed, and the cosine was our x value. Let's look at this one. So this is just kind of review. You don't have to write this down. The opposite side of this 45-degree angle for sine is square roots of 2 over 2, and the hypotenuse is 1. That would simplify to just square roots of 2 over 2. And the cosine, the adjacent, is also square roots of 2 over 2 divided by the hypotenuse. So if we look at our two values for there, notice those are our ordered pair that we have. And in this ordered pair, they're the same thing. But sine is, once again, our y value, and cosine is our x value. Let's try this last one real quick for the 60 degrees. Opposite the 60 degrees for sine is square roots of 3 over 2, and the hypotenuse is 1. That would simplify to just that. And then the same thing with the cosine, adjacent over hypotenuse. And what we should be able to see from those ordered pairs and using SOHCAHTOA is, once again, the sine is our y value and the cosine is our x value. So what this tells us is, in terms of ordered pairs, cosine is x and sine is y. So what about tangent? Well, tangent, remember, is just opposite over adjacent, which opposite in all these cases will be our y, and adjacent would be our x. So if tangent is opposite over adjacent, 1/2 divided by square root of 3 over 2 would look like this. And then we'd have to remember, if I'm asking that, some of these, I mean, you'll get practice with it. It's kind of messy, but where's my work for that? Did I show that? Oh, I guess I didn't show that work yet. But we'll talk about tangent here later. So using the unit circle, you do need to know this, but we're going to start off by just kind of doing some quick examples. So when theta is equal to 30 degrees, what are the following? So sine of 30 degrees, we're looking strictly at our y value. So we need to locate where our 30 degree is, look at our y, that is just 1/2. Cosine, we need to understand that that is x. So we need to look where 30 degrees, the x value at 30 degrees, which is square root of 3 over 2. And tangent, we need to look at y over x. So we have to do a little bit of math here. If I do a fraction divided by a fraction, I just rewrite that as multiplication where I flip the second guy. These two, the 2's are going to cancel, and then I need to rationalize my denominator to get square roots of 3 over 3. So the sine, cosine, and tangent all have these different values with them. All right, so let's use our unit circle for the cosine of 45 degrees. We should be looking at where 45 degrees is, and cosine is x, so we should get square roots of 2 over 2. Sine of pi over 3, that's going to be the 60 degree one, the last line, so that is our y value. That should be square roots of 3 over 2. Sine of pi over 2, that is our up and down, that's our 90 degrees. So we've gone up 1 over to left to right 0, and sine is our y value. So sine of pi over 2 should just be 1. Cosine of 60 degrees should just be, if we locate that, that is our x value, 1/2. Tangent, all the tangents, we have to do y over x and do a little bit more math. So tangent of 60 degrees would be, let's see, that's square roots of 3 over 2 divided by 1/2. So notice I write it out like this, then I flip the second guy and I just cancel, and that would simplify to just square roots of 3. Pi over 4 is the 45 degree angle. Hey, that's an easy one. We're just doing y over x, which is square roots of 2 over 2 divided by itself, which is just 1. And then pi over 6 would be 1/2 divided by square root of 3 over 2. And if I flip that and cancel everything, I just get square root of 3 over 3. Let's look at the axes part. So sine of pi, that would go halfway around. We're looking at the y value. So if I go on the 180 mark, the y value should be -1. 0. The x value is -1. Cosine of 3 pi over 2, that is the x value at the 270 degree mark, 3 pi over 2. And that should be 0. And then I don't know if we've gone through. Yeah, we did. Okay. Tangent of 360. So all the way around the circle, we have y over x. So that y value is 0. The x value is 1. 0 divided by 1 is just 0. And the tangent of 90 degrees, our y value is 1 and our x value is 0. 1 divided by 0, or anything divided by 0, is undefined. So the tangent of 90 degrees is undefined. Okay, so real quick, we're going to talk about how to memorize some of this stuff going forward. And I would encourage you to, every day when we get here, you do a quick sketch of this first quadrant, and everything's going to tie back to this. So the idea is you should be able to tell me the x and y value of any ordered pair around the unit circle by knowing cosine is x and sine is y. Once we know quadrant 1 of the unit circle, we can apply this to all other quadrants using reference angles, bringing them all back to quadrant 1 between 0 and 90 degrees. The only difference will be the signs of the x and y in these quadrants. The slope of these lines, the terminal sides, is the tangent line y over x. Okay, so I just got done saying this. Each day of notes, practice quiz, I would go through and write down kind of what I'm about to show you with this trick and shortcut. So the shortcut works like this. Start just by writing quadrant 1. Do like a little L shape, and you don't even have to write the circle, or draw the circle. We do need to know our axes, so we do need to label the 1, 0, and the 0, 1, and then the 90, pi over 2, and 0, 3, 60, pi, so on and so forth. But the trick works like this. With the 30, 60, and 45 degree mark, we're going to set up parentheses for our ordered pairs, so that's the first thing we do. And then from the top down for our x values, we're going to number them 1, 2, 3. And then from where we left off, so from the bottom to the top, we're going to start over 1, 2, 3, like that. And then from here, we're going to take the square root of every numerator and simplify. So all of these, the only ones that simplify here is the square root of 1. So the square root of 1 is just 1. So I'm not going to actually write this every single time. I'm just going to hopefully remember that the square root of 1 is just 1. And let's see. Write all values over 2. And there we go. And so that's quadrant 1. So if you can remember this, you're going to practice this every single day. So you get used to this, and then we'll talk about how to actually do it all together. So to do it by hand, I'll show you kind of what I would do. So I would start off by saying that's 1, 0, this is 0, 1. Draw my 3 lines like this, and I just go 1, 2, 3, 1, 2, 3, over 2, over 2, over 2, over 2, over 2. It doesn't have to be pretty, and then just make everything that's not 1 in square roots. And that way, and then hopefully we know that that's 30, 45, and 60. And if you need to write pi over 6, pi over 4, and pi over 3, then do that as well. Okay. So this should be done in like 20 seconds type of thing. All right, and that's all I've got for that, I believe.